Alright, today we're going to go over lesson 2.14, Reasoning Part 3. And just like usual, please don't forget to add your course name and section number with all communication. And for this group, you would be 203A or 204A, and you would be section 1 through 9, 1 through 7. Okay. Our objectives today are to work on writing those two-column proofs and to use constructions with compass and straight edge or technology to relate multiple reflections to translations or rotations. And so we're going to be doing something a little bit different in today's lesson because I'm going to be showing you GeoGebra and the steps to actually do the constructions. First, we're going to go over isometry. Remember, isometry is a transformation that preserves the size and shape of an object's original image. That was in Unit 1. Examples of isometric transformations would be rotation, reflection, and translation. And our first GeoGebra activity. In this activity, you will make a construction that shows the image of a figure reflected across two parallel lines. And what I'm doing is going over the lesson, or actually the study guide. They give you some instructions on doing reflections and translations. And I'm just going to go through that with you. And if you would like to do it on your own, which I highly suggest, you can just play and push pause and keep up with me. So if you want to stop and pause right now and open up your student guide or open up GeoGebra and do this along with me, now would be a good time to do that. Okay, here we are with GeoGebra. And if you'll notice, I think usually when you open it up, this is the default screen that you'll see. And we want to get rid of all this, but let's read the instructions first. Number 1 in the student guide says, on the View menu, select Grid. And from the same menu, select Input Bar. The input bar should appear at the bottom of the worksheet below the drawing pad. Now, they've upgraded GeoGebra several times since they wrote these instructions. Look what I'm going to do to get rid of all this stuff. Go up to View, and you don't see anything there that says Grid. Okay? So that's kind of confusing. So what I want you to do is click this X, and da-da-da, look how this stuff shows up. Okay? If I click on this, those axes disappear. If I click on it again, they come back, but I want them to be gone. See how it's a blank screen now? If I click here, bam, I have a grid. Grid's gone. Grid's back. Okay. And notice in the View, they do have the input bar choice. Look down at the bottom of the screen, it says input. It's got a long white bar. If I click on this, it goes away. I click on it again, it comes back. I want it there in this example. Okay, on number 2, it says in the input bar, type x equals 0. So I'm going to come to the input bar, I'm going to type x equals 0. And look what happens. There's a line where x would equal 0. And then it says to go in and type x equals 2. Oops, that's a W, not a 2. And there we have a 2. So that was pretty easy. And now we have 2 vertical lines in our grid. Okay, it says to the left of the line on the left, which is x equals 0, construct triangle ABC. So you can see my cursor's right on the x equals 0 line. Over here, they're wanting us to construct a triangle ABC. And it doesn't matter what it looks like, just as long as it's a triangle. Oops. So I went from A to B to C, and now I'm going to go back to A to complete my triangle. So there you go, it's done. All right. It says, on step number 4, it says select the reflect object about line tool. Drag to select the entire triangle, then click on the leftmost line to reflect the object across this line. Label the vertices of the reflected triangle A prime, B prime, and C prime. Okay, here's the reflect across the line tool. See how the yellow tab even says reflect object about the line. You click on that. Then you're going to come over here with your cursor, and we're going to highlight triangle ABC. Then we're going to click on the x equals 0 line or the leftmost line. And look how it reflected our triangle over that line. And see how it's an exact reflection? You've got the equal distance from C to x equals 0, and then from x equals 0 to C prime. Okay. They've already labeled the points for you, so you don't have to do that. It told you to do that in the instructions, but you don't have to because it's already done. Okay, step 5 says reflect triangle A prime, B prime, C prime across the rightmost line and label the vertices of this third triangle. It's going to be A double prime, B double prime, C double prime. So we're going to click on this box again. We're going to highlight the triangle. Let me highlight that better. Click on there, highlight my triangle, and then I'm going to click the line that I want it to reflect across. And look what happens. Okay, and see how I said double prime? It's got 2 little tick marks up there. Okay. The questions I want to ask you right now is how would you describe the result of reflecting a figure across 2 parallel lines? So I took this figure right here, ABC. I reflected it across the first parallel line. Then I reflected it across the second parallel line. So what it looks like to me is if I take this figure and I reflect it across 2 parallel lines, it's not really a reflection anymore, it's a translation. And hopefully you can see that. Because remember, a translation just moves from one point to another. It doesn't change its positions at all. Okay, the next one says, how can you move the lines of reflection to place the third reflection, the one that I've got my cursor on right here, far from triangle ABC? Well, what you do is I'm going to take this line, you've got to click on the arrow palette right there. Okay, let me see, it says move, drag, or select objects. Okay, so if I want to move an object, I have to click on that arrow. I'm going to come to x equals 2, and I'm going to move it over here. Okay, so I've moved it far, far away. Okay, the next question says, if you double the distance between the lines of reflection, what happens to the distance between the third reflection and triangle ABC? So let me go back here. When x equals 2, if I double that distance, it also doubles the distance between the 2 translations, or the translation. The original, let's call it, remember, the pre-image and the new image. If I double this line, I went from x equals 2 to x equals 4, then the distance between my pre-image and my new image is also doubled. Okay. What conjecture can we make about this? Watching this activity, what conjecture can we make? So the conjecture that we can make about this project was that when you take and you reflect a pre-image across 2 parallel lines, right here, then you have an effect. When you reflect a pre-image across 2 parallel lines, you have created a translation. That's our conjecture. Okay? When you read through the LMS, they actually have a proof that proves this conjecture. So you need to be sure and read that. I've gone through and done the GeoGebra project with you, hopefully not for you, and you need to go through the lesson and look at the proof and see how what we just did can really happen. Okay, what you need to do now that we finished that lesson, you need to go to your file and you can click on New Window and it will open up a new window that looks just like this one I have here. And remember, we want to get rid of all this right here. So I'm going to click this, click that axis, and it gives me a blank drawing board. Okay, for the next GeoGebra project, what they want you to do is construct a pentagon on the left side of the drawing pad. So we're going to go over here to polygon, and remember a pentagon has 5 sides, so I'm going to say 1, 2, 3, 4, that's 3, 4, 5 sides. And then it tells me to construct 3 non-collinear points to the right of your polygon. So I'm pushing the point button, and I'm going to construct 3 more points, just like that are non-collinear, which means they're not in a straight line. And then I need to construct a line that goes through the points F and G. I'm going to go to the line tool. I'm going to click on point F. I'm going to click on point G. Then I'm going to create another line. I'm going to go to point F and point H. Again, these instructions are in your student guide. That's where I'm reading them from right now. Okay, now what they want us to do is to reflect this pentagon over the line FG. So I'm going to go over here to reflect the object about the line. I'm going to highlight this pentagon, and then I'm going to highlight the line FG. Then looky there. I got my reflected polygon over there. Alright, now they want us to reflect pentagon, this new one that I've created, they want us to reflect it across the line FH. So I select it just by highlighting it like I just did, and then I select the line. Notice up here it tells you what to do. It says reflect object about line, select object to reflect, then line of reflection. So I'm clicking my line of reflection. And looky there. Okay, now the instructions say move the points F, G, and H that you use to draw the lines. In this way, you can change the angle between the 2 lines and observe what happens when you move each point. So I'm going to move point G here. You know what? I'm going to click on this move tool. You can move your screen where it's more in the center, just like that. I'm going to come back over here to the select tool. I'm going to select point G and watch what happens when I move it. Isn't that cool? And you honor students that are working on your tessellations, this is part of what you're going to do with your tessellations, is reflections. Now if I move point H, it just moves that object all by itself. Okay, let me get my points back where they need to be. Alright. I don't think, if you move F, look, it just moves it all over. Okay, what they're wanting you to see really though in this one, it's like if I move point G, I want to go back to point H. If I move point H, look how this ends up being a rotation. I took a reflection and now I'm rotating it. Alright, let's see what questions they're asking about this. How would you describe the result of reflecting a figure across 2 intersecting lines? And what you're doing is you're reflecting. You're reflecting, when you do this reflection across 2 intersecting lines, it's just like completing a rotation about the point of intersection. Okay, there's your point of intersection. We're rotating. We've reflected it, and we've taken that reflected figure and we're rotating it about the point of intersection. Okay, that's one of the things we need to get out of that one. All right, so those were our 2 lessons from GeoGebra that will help you with the proof information and the LMS. And I do hope you followed along with me and work those yourself so you can become better acquainted with GeoGebra. Alright, let's look at a two-column proof. This proof says we're given the measure angle 1 plus measure angle 2 equals 180. So I can't mark very well on this board, so I'm just going to let you know that here we've got the measure angle 1. Here. You've got this measure of angle 1 and this measure of angle 2, which that's a real bad drawing. There we go. Those two angles right there equal 180 degrees. What we're going to need to prove is that the measure of angle 3 is congruent to the measure of angle 4. So, I've written my given down. Alright, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And this is in your problem set, but what I've done, of course, is added the if-then statements to let you see how it all flows together. And also, I've added some steps to it, because if you were to just follow what was in the problem set, your if-thens wouldn't connect like I've been showing you they will. So I added some steps so you can see how they all connect. Now, when you're really, really good at doing proofs, you can eliminate some of the steps, okay, like they did in the problem set. Alright, there's our given, and I just put given under the reasons. So if the measure of angle 1 plus the measure of angle 2 equals 180 degrees, I can also say that angle 2 and angle 3 are vertical angles. And you remember in the last lesson I put definition of vertical angles, and I said, we don't really have an if-then statement. Well, the angle 2 and 3 being vertical angles, it's really a given over here. Because we can look at the picture and tell they're vertical angles. But instead of writing given, we write down definition of vertical angles. So if angle 2 and 3 are vertical angles, that means that angle 2 is congruent to angle 3. And the reason I know that is because of the vertical angle theorem. And look here how I made my if match my previous statement, and my then matches my current statement. Alright? So next, since these two guys are congruent to each other, I know they're going to equal each other. The measures are going to equal each other. And that would be the angle congruence postulate. Now, if you were to write down something like definition of congruence or definition of equality, I would accept that as well. But the angle congruence postulate is the correct way to write it down. Now, notice how my if matches my previous statement, my then matches my current statement. So, now I'm going to jump out and I'm going to say, well, I know the measure of angle 1 plus the measure of angle 3 is also going to equal 180. Alright, look up here. Measure angle 1 plus measure angle 2 equals 180. 2 is equal to 3, so I bet you can guess we're using the substitution property. Because if angle 2 equals angle 3, then we can substitute angle 3 into this equation. Alright? Now, I know that the measure angle 1 and the measure angle 4, well, I shouldn't say measures, it just say angle 1 and angle 4 are a linear pair. Well, that's kind of a given, because if you look at your picture, you can tell they're a linear pair. Alright? So for that one, I'm just going to put definition of a linear pair. Next, I've got that the measure of angle 1 plus the measure of angle 4 equals 180 degrees. And for my reason, it's the linear pair postulate. And look how I matched my if with my previous statement that they're a linear pair, and my current statement that they're supplementary to my equation over here saying they equal 180. The next statement says, if the measure of angle 1 plus the measure of angle 3 is going to equal the measure of angle 1 plus the measure of angle 4. Now on this one, you could have used the substitution property or the transitive property, but I decided to use transitive. Look here how if I put my previous statement, and the measure of angle 1 plus the measure of angle 4, that's this previous statement. I guess I should have put in there that they equal each other. Then, angle 3 has to equal angle 4. Angle 3, angle 4. That's my current statement. So then, I can come in and say, well, I just told you guys up here, they equal, so I'm done. Measure angle 3 equals the measure angle 4. And then my reason for that is the subtraction property of equality, which right here is my previous statement, measure angle 1 plus measure angle 3 equals the measure of angle 1 plus measure angle 4. And then, look right here, it says measure angle 1 plus measure angle 3 minus angle 1 equals measure angle 1 plus measure angle 4 minus angle 1. So if I subtract the angle 1, I'm going to be left with my current statement, measure angle 3 equals the measure angle 4. And remember, what I put in bold is what you have to have on your answer sheet. If you include the if-then statements, I'm happy with that. Or if you write them down on a scratch piece of paper, that is fine also. What we learned today was observational as to the following two conjectures in this lesson, that the reflection across two parallel lines is equivalent to a translation of twice the distance between the lines and in a direction perpendicular to the lines. And the second point is the reflection across two intersecting lines is equivalent to a rotation about the point of intersection through twice the measure of the angle between the lines. That's what we did with this, is all we did with GeoGebra. And then you're going to go to your LMS and you're going to read about the proofs. We made the conjectures using GeoGebra. And then we completed another 2-column proof, but it wasn't for these conjectures. It was just another 2-column proof to give us practice. After you watch this, please go through the LMS like I've said many times in this lesson. Read pages 55 through 58 in your reference guide. Please, please, please go practice doing proofs. That's what these problems are. You have the solution set in your lesson resources under the title